So hello everyone, we're going to talk about the sleep sort algorithm. This presentation contains the description, the efficiency, pseudocode, and the sample code of the sorting algorithm. So first, let's talk about the description of the sorting algorithm. So it is a non-comparative sorting algorithm that uses the operating system's ability to sleep threads for a specified amount of time. So sleep sort is a unique and unconventional sorting algorithm that utilizes multi-threading and time delays to arrange a list of numbers. It is not the most efficient sorting method, but it is an intriguing concept that demonstrates the power of parallel processing and underlying mechanisms of operating systems. Uh, this sorting algorithm works by creating a separate thread for each element in the input array, also known as the king of laziness or sleep while sorting. This is sometimes called mysterious sorting algorithm because all this multi-threading process happens in the background at the core of the operating system. We do not get to know anything about what's happening in the background. So, how does sleep sort works? So, for each number in the input list, a separate thread is created. Each each thread is assigned a sleep duration proportional to the value of its corresponding number. This means that threads representing smaller numbers will wake up sooner than the threads representing larger numbers. So once the thread wakes up, it appends its associated number to an output array. This ensures that smaller numbers are added to the output array before the larger ones. So the sorting process is complete when all the threads have woken up and added their numbers to the output array, resulting in a sorted list. So let's talk about the efficiency of this sorting algorithm. The efficiency of sleep sort, it depends on the size of the input array and the distribution of the values in the array. In the best case, if the input size has a value, I have a small value, sorry, then the threads will wake up in a short period of time. However, in the worst case, if the input size has a large value, then the threads will wake up in a much longer to sort the list, resulting in a time complexity of O of n squared. And this means that the time it takes to sort a list using the sleep sort grows quadratically with the number of elements in the list. So, with this, we can determine that this sorting algorithm is not that efficient, especially for the larger numbers. So, the big O notation of this sorting algorithm is O of n.
Hello everyone, my name is Almond and I will be discussing the pseudocode for sleep sorts. We have here the main function. So first, we start. Next, the console receives the list of size n. An iterator is then initialized to 0. And next we have the loop. Now the loop iterates itself the same number of times as the number of elements in the list. What the loop does is that it calls a function. I will be explaining the function in a bit. With the argument set to the list with the iterator as its index, and the increment iterator is then increased by 1, and thus we have the end of the loop and the end of the code. So the function works like this. We store the received argument to x, and the threads are then created with x as their value. The thread is then put to sleep for an x amount of time, which means that the larger the thread, the longer they'll be sleeping, and the smaller the thread, the sooner they'll wake up. And then we will print x as the thread wakes up. So the output should look like an ascending list of integers. So what this function does is that it takes in every element one by one of the list and it, goes through this process. This means that, for example, we have the first element, a thread is then created for it. It is put to sleep and it is printed as long as the conditions to do so are met. So assuming that every element in the list is of different value, this means that every element of the list wakes up on different timings. So It is called sleep sort because metaphorically the elements are put to sleep and they're awakened depending on their, the size of their value. The smaller the element, the faster they wake up. They'll wake up, which means they'll be printed faster. So that's the pseudocode for sleep sort explained.
Okay. Good day, everyone. To follow up on my group weights report, I will now be discussing to you the sample code of our sleep sort algorithm. So, in this algorithm, we included three libraries. So, those are the IOStream, Windows.h, and then Process.h. So, including the Windows.h and Process.h are important because they will be the ones to run our program. So in this sample code, we use three functions. So we have our main function, avoid a sleep function, and then avoid of sleep sort. So I will now be explaining to you. So moving on to the main function first. In our main function, it's here that we initialized our array or our list. So in our list, we have total of 5 items of 723, 11,000, 1,123, 12, 1,521, and 10. And then we use the formula given to us by Sir Adrian to get its size. After getting those two variables, we now call the function sleep sort and then pass the array and then the array size. So moving on to the sleep sort function. So in this function, we created a data type called handle. So this handle data type, it is included in the library of Windows.h. So that is why we included this, because sleep sort algorithm utilizes the ability of our PC to create threads and then to put those threads to sleep. That's why it won't run on online compilers, but it will only run on our own PC or laptop. So after creating the threads, we used a loop so that it loops for every element inside the sys, or in this case the array. So inside our loop, we use the predefined function of begin thread. So this begin thread is a predefined function which returns a data type of handle. That's why we initialize our thread with handle. And then it uses three arguments. So the first argument of the begin thread is ampersand the sleep. So in this argument, it defines where the routine or the function shall begin. So because we use the sleep function, it will, when this line is run, the program will proceed to our void function of the sleep. And then the second argument, it is valued 0 because this second argument determines how many stack will be created when the function or the routine is begun. So since we don't want it to create any stacks, we initialize it, or we set the value to 0, because doing otherwise will it will change the purpose of our sorting the elements of our list. And then lastly, the third argument to be passed on this function is the argument or the values that will be needed by the function. So in this line of code, the third argument is ampersand array at I. So meaning that it's passed by reference, and then it will be passed to the void pointer A. So okay, let's move on now to the sleep function. So in line 6, integer, the value is equal to pointer int pointer A. This line of code is to change the data type from void to integer. That's why it is typed as that. So this is the formula to change from void to integer. And then on line 8, we have the sleep. So this is where the sorting algorithm gets its name. So as I mentioned earlier, the threads are put to sleep, and the sleep time depends on the value that you passed on the function. So it depends on the values of the elements put in our list. So in here, it depends on these values, 723, etc. And then after putting the threads to sleep, when it wakes up, when the thread wakes up, it will now begin printing the elements from our list, and hence the output will be sorted. But the initial list will not be it will not change the arrangement of the initial list, only the output. So that is the sleep sort algorithm, which is also known as the laziest sorting algorithm. So, okay, to further explain the sorting algorithm, I will now be using my IDE. It's just Notepad++ to explain the code better. So, as I said earlier, we included a total of 3 libraries, and then we utilized 3 functions. So the sleep function, sleep sort function, and then our main function. So uh, I'm using this IDE to present to you how the code runs uh, when it is compiled and run on a command prompt. So first, there we go. So okay. So as again, I will be a rundown of the algorithm. So of course, we initialize our array, the size, and then calling the sleep sort function while passing the 2 variables. So after that, moving on to the sleep sort function, we initialize threads of data type handle so that it can accommodate this line of code, line 17. So our threads have the size of the array size or the list size, and then a for loop so that it can iterate on every element of the array. So as I said earlier, the begin thread uses 3 arguments. So the sleep, so that it proceeds to this function. Oops. And then the number of stacks that created, so we want it to be 0, that's why it's 0. And then the argument that should be passed to the function, which is the passed array from our main function. And then the I, that's so that it moves from element to element. And then I forgot to explain this line 19 for the previous video, but it basically it is there to so that uh, every element in our thread is processed, so that it does not stop immediately. So because for this we have 4 arguments here. So first is the size. Of course, the size, we want it to process every element in our list. That's why the size is set to this size, array size, yes. And then the next argument is thread. So it determines which thread will be processed. So we only have one thread, which is named threads. That's why it's there. And then true. This argument can only hold the value true or false. If it's true, it means that you want to process every element on the list. If it's false, then you have to set a different time for the fourth argument, because on the fourth argument, it sets how much time will you allow the this this predefined function to run. Because we set it to infinite, it means that it will continue to run until the last element of our list is processed. So that's basically it. So it allows these lines of code to proceed until the last element of the list is processed. So okay, so let's run it on my command prompt. So we have this g++ -0. Let's name it to please print, and then my file name is sleepsort.cpp. Oops. Okay, so and then this print. So there we go. For this example, we have the values 12, 20, 9, 17, and 28. So we can see here that it printed sorted. So sorted the sorted version of our array. So if we change these values, let's say we have 2, 20, then we have let's say 17, and then let's give it 5, and then let's give it 1. So for this example, let's run it again, and then there we go. So it sorts the algorithm again. But the downside of this algorithm, or rather its implementation, is very limited, because first of all, it cannot process negative values, because the computer cannot sleep for a negative amount of time. It doesn't make sense. So that's why it doesn't accommodate negative values. And another thing is that, uh, as explained earlier or by my groupmate, it's its big O notation is O of n, which is linear. So it means that the larger the list is, the longer it takes to process. So in this example, we only have 5 elements in the list. That's why it is fast. But when the list grows, let's say we have another values here like 30, and then 43, and then let's another one, another 2. Let's give it 99, and then let's say 10, and then 75. When we input all these values, there there goes the error, or the downside of this algorithm. So because it prints depending on the values, or the printing depends on how many time, or how much time does the thread sleep. uh, when the sleep time coincides with each other, um, it it disorganized our input or the output. So let's say the 1 and 1, instead of having the space, it prints beside each other. So that should be separated by a space. And then that's so to further to further present this error, let's use this another code, which basically accommodates changing array sizes. So let's run this on my PC. G++ -0, use the same execution file, please print, and then the name is sleepsort extra.cpp. Okay, so and then please print. So first, let's have a size of 10. So there we go. It's for now it processed easily because the size is smaller. And also another thing is that for this algorithm, I use the srand and then the rand function, so that to generate random values. So it generates a value that is around from 0 to 100. So yeah, and then moving on, let's expand the size, the list size, to 20. So there we go, 20 values. It is sorted, surprisingly. So 2, 4, 8, 13, 21, 28, 44, 50. Yes. Oh, no, this part. It is unsorted for this part. So it printed 74 first before of 73. Why is that? Because from this line here, basically it is the order which the list items or the list elements are generated. So we can see that 74 is found on the beginning part of the list, and then 73 is found on the latter part. So these differences here, when processing this 97, 67, 95, 59, 93, so the time it takes to process these elements here is sufficient enough to complete the sleep time of 74 before the sleep time of 73 finishes. That's why it printed 74 first instead of 73. So that's the downside, or rather the, what's we call here, negative part. Let's just stick to downside. So that's the downside of the sleep sort algorithm. Let's further expand our list. 30. And then, yep, so far it's sorted. Up, another error here. 37 is found here, and then 36 is found here. So for this interval of elements, it is enough to finish processing 37 before finishing processing 36. So for this error, it can be fixed by extending the amount of time the threads sleep. So for this sleep of the value, instead of just using the value of our elements in the list to sleep, we can multiply it by a certain number to extend the sleeping time. However, multiply it by too large of a value and then it takes forever to process because, well, the threads are asleep. So although the computer processes it in milliseconds, if you um, multiplied it too much, then it takes seconds or even minutes. So for this, let's multiply it by 100 milliseconds. So let's see how much time it takes to process. So for now, 10, we have the list size of 10. Okay, it's relatively easy. Up, no. So let's compile it again, and then 10. There. It takes time to process because we multiply it by 100, meaning that the threads are sleeping for 10 times 100 amount in milliseconds, 15 times 100 until 83. That's why it takes time. And if we process a list of size 20, yeah, it will take a while. So that's the downside of this sorting algorithm. So I hope you understand. So that's all. Thank you.